Okay, so we're reviewing what we've been doing for this chapter and a little bit from last chapter. So my blue or my red, doesn't matter which, put my name. Today's date, 2-3-2021. Crazy. Already lost January. Second period. All right, we all good? So what would be the first thing we're supposed to do? When they tell us to simplify by combining like terms, right? We have a tool that we've used that helps us visually separate and keep track of the stuff, right? What's that tool? What thing did we use? We used the table. But we're not going to make that whole big table that has X's, Y's, and XY's and all that because I look at the problem and I don't have X, I don't have Y's. So I only need a table big enough for what I have. I have X squared, and numbers. So that's all I need for my table. X squared, and numbers. All I'm going to need for my table. So X to the second power. Make my next one. X makes my next one number, right? Being weird. Got it? Okay. Number. Line them up after because it's too hard to try and do it as you go. Put the lines between. Everybody should be doing that. You guys know how to do this. We did quite a few of them, right? I'm actually going to change my line so I can keep track. Okay. So we're going to rearrange them, right? We're going to rearrange them into the column where they go. So I see I have an X squared, so that has to go into my X squared column. And its sign goes, so negative 8x to the second power. How do we get to the second power again? I saw some people were having struggles with that. How do we get to the second power again? What buttons do we push? What button do we push to get us that exponent? The shift 6, yeah. Now, after you do the exponent, make sure you arrow to the right to jump off the exponent so you don't keep yourself up in the exponent. Okay, my 5x goes in the x column. I'm back to the x squared, my negative 10x to the second power. And I got to move him over because he's in the way. So don't worry about it being perfect, but just shift it after so it fits. I do not have any more x squared, so that one's done. I do have a negative 3x, so we got to put that in there. Now, I am doing this one a lot. You guys aren't participating very much. And that's because I'm refreshing what I was talking about the table. The next one, I better be seeing participation happen. Okay, so we put everything in their columns, right? We remember this? Everybody remember this? Okay, so now we have to combine them. Okay, now we have to combine them to get our final answer. That says a negative 8x squared with a negative 10x squared. So they're the same sign. What math operation when they're the same sign? What math operation when they're the same sign? addition and keep the sign, right? So what's our sign going to be? Negative, and then we add them. Negative what? Negative what? (18x²). Yeah. If you're going to do it in the chat to show that it's an x², do the shift 6 again. It's going to put that little up arrow looking thing that makes it clear that we're doing the exponent. Okay, negative 18x to the second power. So the same motion you do in Kami, you still do in chat. It'll put this little up arrow thing. Okay. All right, now we go to the next column. Are those two numbers the same sign? No. So when they're not the same sign, what are we supposed to do? When they're not the same sign, what are we supposed to do? Subtract, and then do what? After we subtract, what do we do? Keep the sign of the bigger. So is my answer going to be positive or negative? Look at the X column. The 5 is bigger, so it's positive. Okay, so I'm going to have a positive, positive 2x. Yes. Now we look at our last column. Are they the same sign? No. So we're going to do what? Subtract and subtract to do what? Keep the sign on the bigger. So for the last column, the number column, what's the sign of my final answer going to be? Negative, because 29 is bigger than 27 and it has a negative sign. Negative, how much is 29 take away 7? 29 take away 27. 29 take away 27 is 2. Okay, we already had the negative. All right, that subtraction is negative. Okay, and that is our final answer. So we put our final answer. Okay, now you guys are telling me, what's my first column going to be? What's my first column going to be? Looking at this problem, what am I going to say my first column is? A y². Thank you for putting a little, that was right. Okay, a y², because I don't have any x's in this one, I have y's. So my first column has to be y to the second power, y². Next column over is going to be what, guys? Next column over is going to be what? Just a y, correct. And then our last column is always the number column. Okay, no matter what, it's always the number column. Okay, let's get them all lined up. Don't make them too skinny though, because you know, with the numbers in front and things like that, it makes it difficult. Go get our line. All right, so first thing in the question is going to go into what column? We read a question from left to right, we put them in from left to right. So what are we going to put first? What are we going to put first? Just a plain old y in the plain old y column. Now, normally, isn't there supposed to be a number in front of it? So if I don't have a number in front of it, how many are there? 1 is there, exactly. Because as soon as I write a y, there's a y, right? It's just if I get more than 1 that there's 2s and 3s and stuff like that. Okay, Next thing, ooh, another y. So we're going to put that down below. Okay. What's my next thing I'm going to put? -2. Then what do I put? Four y to the second power, exactly. 4y to the second power. Okay. Then what do I put? Just a y squared. And then I end up with another -2, right? Okay. So I'm going to make it look prettier before I go combining things, so it doesn't mess with me. Okay. So now we're going to go make our answer. First column, are they the same sign or different signs? First column, same sign or different? Same. So when they're the same sign, what are we allowed to do? Add and keep the sign. So what are we going to say? How many y squareds do we have? How many y squareds do we have? 5 of them, because we had 4, and we remember as soon as we see one, there's one more. So this y squared is technically 1y squared. So when you say it to yourself, 4y squared plus 1 more, 5y squared. Okay, arrow off. How many y's do we have? How many y's do we have? 2 y's, yes. Oh, what kind of 2 y's? Positive or negative? Positive, so I have to put a plus and then a 2y. Okay, last column. Are those the same sign or different signs? Same sign. So what are we allowed to do? Add and keep, right? So what's my sign going to be? Negative. And what's my answer going to be? Negative what? 4. Yep. Okay, does anybody have questions about those? This piece here that we're doing is a big component for tomorrow's quiz. Simplifying expressions, combining like terms. So do we have any questions about how the charts work? Did we forget how they worked, or are we okay? All right, then I'm going to move on to the next thing. We're solving. Okay, we're solving. So do I see any extra stuff on one side or the other, like more than one X or more than one number or parentheses or any of that? Do either of these two have that? No. So we get to go straight to the balance beam. We get to go straight to making our big zeros and our big ones. Okay. What do I have to make first? A big 0 or a big 1? What do I have to make first? The big 0 or the big 1? Because our goal is to get the piece that has an X by itself. So would I be doing a big 0 or a big 1? Big 0. Okay, so we need to get rid of what's not an X. So I see that there's this +8 right here, right? So we need to big 0 that +8. So what are we going to do? We need to big 0 that +8. So what do we need to do? Subtract 8 from both sides. Yes. So I'm going to put in a -8 on the left. And I got to put in a -8 on the right, because the balance beam, we have to keep it balanced. It's like a scale. Whatever you do to one side, you have to do to the other. All right. So I made a big 0, so I can cross that out. It turned into 0 and things plus 0 don't matter anymore. What's left on the left side? After we big 0 that 8, what's still there? What's still there? The 3x. And now that 3x is going to be equal to what happens to the other side when we did the big 0, right? So what's the other side say? It's not 17 anymore, is it? It's 17 take away 8, 9. Okay? We okay so far? I should see more participation if you guys want participation points. It's up to you. Okay, so did I finish all my big zeros? Do I have any big zeros left? Any more adding and subtracting? Is there any more adding and subtracting in that problem left? No. So now we get to go to the big 1. Okay, we're going to the big 1. So to make a big 1, where do I look? How do I know what I'm turning into a big 1? Where do I look? We look at what's in front of the x. Yes, we look at what's in front of the x. Okay, so what's in front of the x that needs to be made into a 1? The 3. How do we turn a 3 into a 1? Divide both sides by 3. Yes. So I have a 3x that's dividing by 3. And an arrow off. And it's going to equal a 9 divided by a 3. Because whatever we do on the left side, we have to do on the right side too. We have to keep it balanced. We created the big 1. What's left on this left-hand side? After we get the 3 out of there, what's still there? What's still there? The x. That is correct. And it's going to equal the right side. Do the math. What's on the right side? Do the math. 3. Okay. And that is our final answer. Does it say check your answer in the instructions? No. So we're done with that one. We're on to the next one. Okay. Do I have any extra X's, Y's, extra parentheses, any of that for B? Do I have any of those for B? No. So we get to go to the big 0. Okay. We get to go right to the balance. Put our line in. What needs to go so the X part is by itself? What needs to be big zeroed? The 7. So how are we going to big 0 that 7? By subtracting 7 from both sides. Yes. So subtract 7 from the left. So we have to go over and subtract 7 from the right. Whatever we do on the left, we have to do on the right. That's where we draw the line to keep us straight where things got to go. We never go to the same side. It always has to go over the line. Okay. So we got a big 0 done here. What is left on the left-hand side after we big 0 the 7 out of there? After we big 0 our 7 out of there, we still have the negative x. Yes, we still have the negative x. Okay, good catch. Negative x, not just an x. All right, so we have a negative x that's going to equal our math. And that says, are those the same sign, the 3 and the 7? Are those the 3 sign? Are those the same sign? No. So what are we going to do because they're not the same sign? Subtract and keep the sign of the bigger, which is why Brian said -4. Okay. So we've done our big 0. What do we still have to do? Because there's something with the x. There's actually something still there with that x that needs to go. We're going to have to divide to make the big one, yes. But what are we dividing by? What's with the x that needs to go? The negative sign. Remember we said when we see a letter, how many is really there? If all we see is a letter, there's one there. So what we really have in front of that x is a -1. So we need to do a big 0 to a -1, okay? Oh no, a big 1 to a -1. It sounds really funny, a big 1 to a -1. So we are taking a negative x and we are dividing it by a -1. And make sure the x is on top, not in front. It always likes to put it in front of the equal sign, but we don't want it there at the moment. We want it on top. Okay, negative x divided by -1 has to equal -4, oops, divided by -1. Okay, now what does negative divided by negative get us? Positive. So the final answer of this is that our x equals 4. Okay, so we need to always remember that if there's no number in front of the x, then we are doing a 1. And since it was a negative, I'm going to highlight this because that's what we had to big 1. And I'm going to go back and do this. This was what we had to big 1. This is what we had to big 1. And the blue is what we had to big 0. Okay, so let's make a note in here. Anytime you see a variable alone, right? There is one of them. If it is a negative, one second, I'm going to move him down. Variable, it is a -1, okay? That way we have that note for us to remind us. Okay. I see they gave me an expression. Why is this one called an expression, but number 2 is called an equation? What's different between number 3's question and number 2's question that makes number 2 equation and number 3 expression? Okay, so close, really close, Alexis. Okay, look at the actual formatting and I'll highlight it and then I'm going to take the highlight out so you don't need to keep it. We are looking at this 3x minus 8 is the question, and this one says 3x plus 8 equals 17. What's different between those pieces? The 3x minus 8 and the 3x plus 8 equals 17. Oh, expressions have no equal signs. Exactly. Since they have no equal signs, the only way you can get an answer for them is like Alexis mentioned, they tell you what the letter stands for, how much the letter stands for. So if they do not tell you how much the letter stands for, you cannot do anything but make it cleaner like what we did in number 1. Okay, this is already as clean as it can get. So they had to give us what that letter was worth if they wanted just to do something else to it. Okay, so we take what they tell us, put it in parentheses instead of writing an X. So there's no more X. X is gone. All gone X because X was replaced, substituted with that -2. Okay, X was substituted with that -2. All right. So with that in mind, we now need to do the math, right? Do the math. What does 3 times -2 get us? What does 3 times -2 get us? A negative of a 3 times 2, because I only see one negative sign. And whenever there's only one, it stays negative. So a negative of a 3 times 2. What's a 3 times a 2? 6. Okay, so it's a -6, and we still have this -8 back here because we didn't do anything with it yet. Okay, now I have to combine them. Are they the same sign? Are those the same sign? Yes, because I don't see any plus anywhere. Okay, if I saw plus negative, it would still be the same sign. Okay, so they're the same sign. What are we allowed to do when they're the same sign? What am I going to do? Same sign. What do we do? Add and keep the sign. So -6 plus 8. -14. Done. Don't overthink these. This is what was on last week's quiz, these substituting ones. Okay, I don't see an equal sign. They gave me values, so I'm going to stick the values in for parentheses 3 plus 3 parentheses. Now, did they give me an x or an x squared? They gave me the value of x or x squared. Is that the value of an x or an x squared? And right here, is that a value of an x or an x squared? Do you see a power of 2 on this equals -2? No. So they gave us an x. So we still have to show power of 2. Okay. So be careful that you don't leave off pieces when you replace the letter. All the parts you don't use still have to be there. Okay. According to our rules, I have to do this square first. So 4 parentheses 3 is going to sit there. Not 30. 3. Plus the 3 parentheses. I have to solve a -2 times a -2. What's a -2 times a -2 going to get us? +4. Okay. And I have a 3 times 4 and a 4 times 3, which means the answer for both of these parentheses are the same. What? 12. So this is 12 plus 12. Okay, final answer. What is 12 plus 12? 24. Okay, so be careful when you're doing the substituting that you don't lose exponents and things like that. Okay, and this is what we did on last week's quiz, this process that we just did here. Okay, put a circle on it. That's our final answer. More fun with sound effects. All right, so now we're reviewing some stuff that we did in chapter 1 when we talked about unit rates and we talked about our proportionality and stuff. All right, so we need to set up our proportionality like we did before. Okay, so our first thing is we have to do and identify what unit rate is. Unit rate is how much only one of the item will cost. So that's unit rate. Okay, that's our definition of unit rate. We did it before, but I'm refreshing for us. So what math do I need to do to find out how much only 1 pound of chicken costs? Because they want to know the cost per pound. So what am I going to do to find how much only 1 pound of chicken costs? We're going to divide. We're going to divide what? The 21 by the 6. So I'm going to put my steps in here. My unit rate will equal, and then now I'm going to put the equation box in. The 21 divided by the 6. So we have to go do the math. Now it's money, right? And we know money has decimals, and that's okay. Money has decimals, and that's okay. First thing, though, we should simplify that fraction. What can I divide 21 and 6 by? What can they both reduce by? What divides into 21 and into 6? What divides into 21 and into 6? How do we make 21 when we multiply? How do we make 21 when we multiply? Seven times 3. How do we make 6? Three times 2. So what did they share? 3. So both of these can be divided by 3. And I'm actually going to use the divided by symbol. Okay. Divided by symbol, maybe, because I want to show something a little bit different. Divided by 3 on the top level. So I can divide by 3 on the bottom level to simplify my fraction. If I do that, I get 7 over 2, right? 2. Because the 3's would cancel to a big 1. These would cancel out because they become a big 1, just like in our other problems, okay? So I have to set 2 into 7. How many 2's are in 7? How many 2's are in 7? 2 times what gets us close to 7? 2 times 3. And then there would be how much left over? There would be 1 left over. So reviewing of fraction practice. I right now have 3 and 1/2 because that's how it works. Whatever's remaining gets put over the divisor. Okay, 3 and 1/2 would be what that is. But this is money, and we don't say $3.50. How would we say $3.50 in our money system? What would it look like? What does $3.50 look like with a money sign on it? How much is $1/2 worth? $3.50 per pound. But this was a word problem, so we have to do our word problem answer. Who is buying the chicken? Who's buying the chicken? Look on it. Who's buying the chicken? Michael's buying the chicken? No. Who's buying the chicken? Alfred. So Alfred would pay $3.50 per pound for the chicken, period. Okay. So now we have to do this new setup. We are going to take our original situation, which we reduced to 7/2. And we're going to set it equal to, because that's the unit rate, right? 7/2 was my unit rate in fraction form. 7/2, right? And we're going to set it equal to how much money it's going to cost us for 30 pounds instead. Our proportion that we did last chapter, that we did our cross multiply for last chapter. And we remembered we go top to bottom, bottom to top. I think I used the line features last time, and I'm going to go do it again this time. Yep, I did, because it's prettier. So we have to figure out how much our cross multiply is. Okay, when I cross multiply, I do the 2 times the x, which would be what? What's 2 times the x? 2x. And it has to equal the 7 times the 30, right? Because when we do the cross multiply, it becomes a straight line, no more fraction. Which piece can the 2 divide? Because we have to big one the 2. Which piece can the 2 divide into? Because we're going to big one the 2. Who is going to get the 2 on the other side, though? The 7 or the 30? The 30. So 7 times 30 reduced by 2. If I reduce 30 by 2, I get what number? 15. So I'm going to be multiplying a 7 times a 15. So go use your calculator and tell me what that is. So I would have an x equals 7 times 15. Final answer of 7 times 15 is what we need. What are we going to get? Okay, equals, now 105 what? What were we measuring by for the top of the fraction? Was the top of the fraction the pounds, or was the top of the fraction the money? Was the top of the fraction the pounds, or the top of the fraction the money? Back in part A, the 21 was what? That's the top of the fraction. Was that pounds or was that money? It was money. So my X here is going to be money, because it asks how much should 30 pounds cost? So there would be a money sign in it. And so we have to go in here and get the money sign. Where are you? It's in here somewhere, isn't it? I don't see a money sign in here. That's silly. So we're going to write this answer as a text box so I can have the money sign. No big deal. X equals $105. So now we're going to do our sentence answer. Who are we talking about that's buying chicken? Who are we talking about that's buying chicken? Who's our person buying chicken, guys? Come on. Who is our person who's buying chicken? Okay, Alfred. So Alfred should pay $105 for 30 pounds of chicken. Okay. We're always going back to the original information. All right. There is where? If you click on for 2 times, shift 4. Okay, so let me try it because I'd like to be able to use the equation box if I can. So if I go x equals, and I do shift 4 twice, thank you. I can do the equation box. I like it better because it just looks prettier. I don't know, just me. Thank you, Charlie. Something new. Okay. So this is our last one. See, look, last one. Consider the following pattern. Consider the following pattern. So, and then we have to draw the next one in the pattern. So we got to see what we got right now. How many squares do I have in my first pattern? We're going to put that first. How many squares do we have in our first pattern? Or boxes, or whatever you want to call them. 4 boxes, okay. How many do we have in our second pattern? 5 boxes, okay. How many do we have in our third pattern? 6 boxes. Okay, so we see that it's doing what? What's our first thing we're noticing? What's our first thing we're noticing is happening? We're increasing by 1. In what location? So if I was to go highlight in question 2, I was going to go highlight in question 2, in figure 2, the figure 1 part, it would be this, right? And if I highlight in 3, the figure 2 part, doing the best we can. It's okay. It would be these, right? So I see that we're adding 1 in at the top row, like Brian mentioned. Okay. So what should I expect for 4? How many boxes? 7. And which way are we making it? Tell me where I'm going to be putting my boxes. So I'm going to go get box. Okay. How am I going to make it? How many tall in the first column? Is that changing? How tall it is in that first little piece of it? Is that changing? No. So I'm going to have 3 tall. And I'm going to go move them. Oops, no, back up. I don't want that. Does it let me shift these around? I'm still learning about some of the tools. Ooh, shift. Okay, wait. And then can I shift the box somewhere? Okay, I'm just going to put them not quite perfectly together. This is not, that's not too bad. I'm going to take this one back off. Okay. So we have our 3 boxes up, right? That's not too bad. I can deal with it. Then do I go straight across for my second row? No. Am I going to go above and across? What do I need to do? Oh, I have to go a little bit diagonal. and across. See, sideways is so much easier than up and down. I'm going to try again. I put my diagonal one a little far away. Too close. Okay. And it doesn't have to be perfect, you know, because we're working with technology we have. All right. And I understand if someone can figure out a way to like move them around, that'd make me super happy if I could make them lined up. But it is what it is. So we're going to finish the table. We had 4 in the first one. We had 5 in the second one. We had 6 in the third one. So how many are we going to have in the fourth one? What did we say? What did we say was in the fourth one? 7. Okay. So if we keep the pattern going, we are adding 1 in, right? We're adding 1 in each time, but we started with how many to begin with? So we have to actually go and figure out what our 0 looked like. What did our 0 row look like? If we added 1 in to the top row, what must 0 have looked like? Yeah, 0 was just the 3 sticks, right? So we started at 3 and we're adding 1 in. We started at 3 and we're adding 1 in. That means this table is showing me the equation that our number of tiles, which is they say is y, is equal to our figure plus 3. And let's go try it out. Okay, let's go try it out. Because we did this when we did last chapter, we figured out these equations. So figure 1 plus 3, 4. Figure 2 plus 3, 5. Figure 3, 3 plus 3, 6. 4 plus 3, 7. So how many tiles will be in 10? So our equation is y equals our spot plus 3. And our spot is the number 10. That is our x value. That 10. So I'm going to go put it in. That my number of tiles is equal to 10 plus 3. So how many? Altogether. Location plus 3. So what are we going to say? How many tiles will be in the 10th one? 13 tiles. Okay. It is a question in words, so we're going to answer it with words. There will be 13 tiles in the 10th figure because we take figure number plus 3. I'll be fixing it to find the answer. Okay. That's what we did. Question about that? Because you do have something on your worksheet about it that you're going to be doing as part of your assignment. That was review from last chapter. Any questions about that stuff? Any questions about that stuff? Okay, hit turn in for me, please. Done or not, just turn it in. Don't worry about it. Hit turn in. I'm going to go stop sharing. Remember, I don't grade the notes on being perfect.